right, here's an example using the ideal gas law. Imagine that you decide you're going to give a heart-shaped balloon, helium balloon, to your sweetheart. It has a volume of 0.031 cubic meters, and you have been storing it in a 20 degrees Celsius room with an internal pressure. The balloon has an internal pressure of 1.06 atmospheres. How many moles of helium are you gifting your love? And how many atoms are you gifting them? And what is the mass of those atoms? All right, it's very romantic to gift scientific principles. All right, now of course this is helium. You're also giving them the mylar that the balloon is made out of. But we're just gonna look at the helium. So let's just write down what we have. We know that the volume of our balloon is 0.31 meters cubed. The temperature that we have that balloon at is 20 degrees Celsius. The pressure on the inside of that balloon is 1.05 atmospheres. So a couple little emphasis on the hints that we have to pay attention to. And we are curious, of course, about the number of moles, the number of atoms, and the mass of the helium. Okay, if I want to look at a gas in effect of the temperature and the pressure and the volume, I use the ideal gas law. So we have pressure times volume, of course, is equal to nRT. We have to keep in mind that I need things in standard units. So I first need my temperature in standard units. The temperature is given in degrees Celsius. I need it to be in Kelvin. So we know that Kelvin is equal to the degrees Celsius plus 273.15. And so we find our temperature that's going to be useful for us in our equation is 293.15 Kelvin. I also need my pressure in standard units. We're given the pressure in atmospheres, and we know that 1.05 atmosphere, there's 1 atmosphere in 1.0133 times 10 to the 5th newtons per meter squared. And so my pressure is 1.064 times 10 to the 5th newtons per meter squared. I would encourage you to be doing these problems actually on your calculator. Check my math. Sometimes I make a little mistake. You can certainly leave me a message and let me know that. And I will make sure it's in the notes for that video. But also it's good practice to make sure that you're being really comfortable with your calculator. Okay, given these standard units, then I can use R in its standard unit, which is a reminder is 8.314 joules per mole times Kelvin. All right, so taking my equation and rewriting it, I have N is equal to PV over RT. So I just brought my RT on both sides. And now it's pretty plug and chug. So my pressure, 1.064 times 10 to the 5th. My volume of 0.31. All divided by, and that is where the mistake is. Like this something isn't feeling right. So it's 0.31, but it's supposed to be 0.031. So my numbers are not going to match my already calculated key if I use 0.31. That seemed awful big for my balloon. So we're going to pop that in. And we're going to pop that in so that the math works out for my solution. R is 8.314. And my temperature in Kelvin is 293.15. So we find the number of moles that we are gifting our love is 1.353 moles of helium atoms. So how many helium atoms are there? So the number of helium atoms is going to equal my moles, 1.353. And we know that in 1 mole, I have 6.02 times 10 to the 23 atoms. And so the number of atoms are 8.147 times 10 to the 24 atoms of helium. And how much do those atoms of helium weigh? Well, we know that how massive are they? The mass is going to equal to our atomic mass, right? The atomic mass of helium times the number of moles I have. So we can use the mole one. So the atomic mass of helium is 4.00 grams per mole times 1.353 moles, and I get 5.412 grams of helium that I am giving to my sweetheart in the form of a heart-shaped Mylar balloon. All right, so just using the ideal gas law, a little bit of reminding ourselves of the atomic mass and the converting between atomic mass and molecular mass and real mass, or not molecular mass, but real mass and moles, and kind of a little reminder of that as well. All right, good job.